So the one disadvantage of the machine which we have been seeing till now is that the machine can check the acceptability and the rejectability of a particular language, but we cannot produce any output. We cannot produce any output in that machine. So in that machine, right, we cannot produce any output. So today we are going to discuss a type of finite automata which has the ability to produce output. Okay, the topic of this today's class is automata with output. This is the short form of output, but in exam, please do not use such thing. I'm using this in my class. This is representing output. Okay, so there are two types of such kind of machine. First one is known as Moore machine. Moore machine. Uh, 1 second, you guys, keep on entering. So this is known as Moore machine. For machine also, I'll be using one short form. This is MC. Okay, and then another one is known as Mealy machine. MEALY, Mealy machine. So under this topic, automata with output, we are going to check out this two type of machine. One is known as Moore machine. Another one is known as Mealy machine. So I this is the last entry. Hereafter, I won't allow anyone to enter this class. It's quite disturbing. So today, let me discuss these two machines separately, and then later on we'll be learning how to convert from Moore to Mealy, then Mealy to Moore, like that. Okay. So let me represent this Moore machine by capital M. This. Okay, this is representing Moore machine. I won't allow Srishti Katya to enter. Okay, now the mathematical definition. I'm going to talk about Moore machine. I'm going to talk about Moore machine first. And the mathematical definition of Moore machine is capital Q, comma, summation, comma, delta, comma, del, comma, lambda, comma, Q naught. Okay, Q naught. So let me brief this thing. This is nothing but finite set of states. This is nothing but finite set of states. What we have seen in the case of finite automata, which we have learned already, almost the same. And this is again like an input symbol, finite set of input symbols. And then this is nothing but finite set of this particular will have I need to type what I okay. And then the function this will representing like this q cross summation and q. Let me directly move for the example, and then you'll be understanding what's the I mean what kind of symbol I'm using, what's the purpose for this. I'll go with an example and then I'll come to this. Okay, and then this is as usual initial state. And then this is nothing but mapping function. Which maps from mapping function, which maps from Q to this. Okay. Now, in order to understand this Moore machine, right, let me take up one example. Let me draw one diagram. Let me draw the diagram first and then we'll be explaining. In the previous finite automata, we haven't seen such kind of notation. Okay, this Moore machine. I'll let me complete this and then I'll just explain to it. I'm drawing the state, this circle a little bit bigger. The value associated in each state is nothing but output of the state. Okay, they were like Q naught comma 0, Q1 comma 0, Q3 comma 0. They are the output of this particular state. Hmm. Now we'll do one thing. Let me describe the definition which I have just explained here. Okay, for this particular example, this Moore machine, every state is associated with one output value. So here for Q naught, it's 0. For Q1 is 0. For Q2 is 0. For Q2 is 0. Okay. Now let me fill this definition as per this particular diagram. Now see here. Q is nothing but Q naught comma Q1 comma Q2 comma Q3. There's nothing but finite set of states. 4 states are there. That's why this. And then summation is equal to only zeros and ones we are seeing input symbol. Okay, that's why 0, 1. And then this output symbol I have told, right? Finite set of output. See here, in the output symbol, right? We're seeing only, I'll let me insert one here because you'll get confused. Let me insert 1 here. Okay, so output symbols, how many, what are the types of output symbols we are using? Zeros and ones. So let me use 0, comma 1, this output symbol. And then I have used this one, lambda. It's a mapping function. It's a mapping function from Q to output. It's a mapping function from Q to output. It is nothing but lambda Q naught is nothing but 0. It means what? The output for this Q naught is 0. And then lambda 1 is equal to 1. The output for this 1. Lambda Q2 is equal to 0. Then lambda Q3 is equal to 0. It's a mapping from capital Q, from, set of states to output symbol. So it's a mapping from state to this one, output symbol. Okay, that's the case. And then now, next one. Regarding this Q naught, right? As per in this particular diagram, Q naught is the initial state. I'm not going to specify again here. If you want, you just do it by yourself. And then regarding this transition functions, right? Regarding this transition function, let me just draw the transition table to describe this function. Okay. Let me just, for Moore and Mealy machine, please try to understand the transition table also. Okay. While conversion and all, the transition table will be very helpful. So now let me just write present state. And then this is next state. And then let me just write it, okay? You'll get confused. Let me just write it first. Let me just write 0, 1, then output. Don't get confused. Let me just, oh, Now see here, in this present state category, right, how many states are present in this diagram, in this machine? We'll be listing that one. So there are 4 states, Q0, Q1, Q2, Q3. And Q0 is the initial state. Let me tell you one more thing. In this particular automata with output, right, we don't have any final state. It means what? We are not going to check for acceptability or acceptability or something. We are going to process some input, and then accordingly we just want to get some output. That is the aim for learning this particular machine. Okay, depending on our application, we should choose with what kind of machine to be designed, whether to design an automata with output or the previous NFA or DFA, like it's up to us. Now these are the thing. And then now this is not clear, let me just write it very clearly. Why am I writing 0 and 1 here? It means how many input symbols are here? As per this one, right? How many input symbol? 0, 1. That's why 0, 1. And then once we perform the transition, right, which state we are going to perform the transition, and then the corresponding output. Now let me tell you one thing. For Moore machine, right? For Moore machine, the output values are associated with respect to this state. Okay, say for example, Q0 means already we know the output for this Q0, the output value is 0. Q1 also we know the output value is 1. That's why before filling this internal or columns, right, let me fill this output first. For Q0, right, from the diagram, the output value is 0. For Q1, from the diagram, the output value is 1. So let me just write 1 here. Rest, it's 0. Okay. Now let me start filling this 2 column. Now see here, state Q0. See here, state, let me take another, state Q0, state Q0, and then input 0. State Q0 with input 0. State Q0 with input 0. Where is the transition being performed? From Q0 to Q3. Okay, state Q0. Let me tell you another point. Sometimes your senior you used to get confused with this output value and then input value. Okay, once we stop filling this output column, right, we should avoid as if nothing exists in here and then check out for this edge leveling and all. Okay, so current state is Q0 and then input symbol is 0, where the transition is being performed in right here Q3. Now I need to write here Q3. Okay. Again, state, let me take different, again state Q0. State Q0 with input 1. State Q0 with input 1 where the transition is being performed, Q1. Okay, so let me write Q1. Let me write Q1 here. The next one is Q1. Next one is Q1. Let me check another. Next one is Q1. Next one is Q1. Oh, next one is Q1. Q1 with input 0. Q1 with input 0 is Q1 itself loop. Q1 with input 0 itself loop. So Q1 itself. So let me write Q1. Next one, Q1 with input 1. Q1 with input 1. Q1 with input 1, it's Q2. Q1 with input 1, it's Q2. So let me write Q2. Next one is Q2. Q2, let me select this one. Q2 with input 0, Q2 itself. Q2 with input 0, Q2 itself. And then Q2 with input 1, Q3. Q2 with input 1, Q3. And then next, Q3 with input 0, Q3 itself. Q3 with input 0, Q3 itself. Then I guess I forgot to level this particular 8, this is 1. Now next one is Q3 with input 1. Q3 with input 1 is Q0. Q3 with input 1 is Q0. Q0. Okay, so this transition table, right? What we are seeing, this is state Q, this is the input 0 or 1, whatever. And then as per this, the transition, whether it's Q1 or Q2, whatever, we are filling that one. This is the notation for this transition function. And then this is known as transition table. This is known as transition table for the given Moore machine. Okay. Now, for your understanding purpose, right? Let me take another example. I guess this is enough. Okay, fine. Let me just take another one. Let me take another example. We are going to construct a Moore machine which will print A whenever the machine, whenever 0, 1 is encountered. Okay, so we are going to design a Moore machine. What is the aim for designing that machine means, whenever I counter this 0, 1 substring, right, I'm going to print A. Okay, so now our target is 0, 1. So let me write Q0. I have to insert the output value, but I am not going to insert it right now because my target is Q1, Q2. So when I come across 0, 1, that to print what? A. Okay, that is my opinion. So it is vertical input I'm going to consider, then let me consider other output symbols as alphabetic symbols. Okay. Now another way of representing Moore machine means instead of representing the output value by comma, you can represent this one as like this also. Okay, certain textbook you can find like this. That's also nothing wrong in that one. Now see here, whenever I encounter 0, 1, I just want to print A. So the ending state, right? It has to print A. This is the case. Now, what about the string? What kind of strings we are going to design? If it is going to be 1, 1, 0, 0, 0, 0, it's not going to print A. It will be printing other than that. Okay. So now, if suppose this is 1, 1, 0, 1, it will print 1. And then if suppose in between, if it is 1, 0, then 1, 1, 1, 1, 0, then 1, 1, 1, 1, it should not print A. 1, 0. Only when it encounter 1, 0, 1, then only it has to print A. So here it will be 0. And then one more thing, this is DFA, so we have to check for the completeness of every state that you need to keep in mind. And then after this 1, 0, 0, 0, 1, if this 0, 1, at the end it has to print A. But if suppose if it is 1, 0, 0, then 1, what will happen? 1, 0, 0, then 1, then better it is start from the beginning. If this 1, start from the beginning. If suppose instead of 1, if it is 0, then like this. So 1 means it will encounter. So let me check for something. 00001. Let me check this, 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 this. Initial state is Q naught. The Q naught with 0, Q1. Q1 with 0, Q1. Q1 with 0, again Q1. Again Q1. Q1, 1, Q2. Now Q naught, the output is B. Q1, the output is B. Q1, B, 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 A. Now what about 0, 1, 0, 1, 0, 1? What about this? Let me just check. It will start from Q naught, initial state Q naught. Q naught 0, Q1, Q1 1, Q2, Q2 0, Q1, Q1 1, Q2, Q2 0, Q1, Q1 1, Q2, Q2. Now see here, Q naught output value is B, Q1 output value is B, Q2 output value is A, Q1 output value is B, Q2 output value is A, Q1 output value is B, Q2 output value is A. Now whenever we find this A here, right, it means what? Is encountering 0, 1 here. A means 0, 1. Already encountered 0, 1, and then we are printing A. Again 0, 1, then A. How many times, if like we can count this number of this substring also, okay? But in my particular example, I have designed the Moore machine in such a manner that whenever the machine encounters 0, 1, we have to print A. Okay, this is one example of Moore machine. I guess this is enough practice by yourself for more. Then now let me move to another type of automata with output versus milling machine. This is milling machine. This is milling machine. There are two types. First one completed. Next one is known as milling machine. Again, in this case, right? Mathematically, it could be. This is E. I'll just say. Same definition, same, this, but only difference will be in here. Okay, so regarding this, let me explain this with one example, and then you'll be knowing. And this, it will be summation, this. Okay, this will be the, what to say? Notation wise, it will be a bit. Let me, the same machine, the same Moore machine as milling machine. Let me just design. Let me take one example and then I'll explain about it. So whenever I encounter 0, 1s, whenever I encounter 0, 1s, we'll be printing A. Okay, just now we have just designed a Moore machine of this kind. So let me design a milling machine of the same. Okay, and then you'll be understanding it. Now, the notation and all, it's a little bit different here. Let me just write it. Q naught, Q1, this is 0, Q2, initial state. Now, whenever I encountered 0, 1, we are going to print A. Now, in the case of milling machine, right, every output is, every input, wait. In the case of Moore machine, what we have seen, every state is associated with output. But in this case, right, every input will be associated with output. So we just want to print whenever we encounter 0, 1, then we will have to print A. That's why I'm doing like this. I guess almost the same. 1B, other than 0, 1, others should be printing B. So let me just, it's almost the same, okay, but checking part, I'll do it. For this one, right, for this milli machine, you please construct the transition table by yourself. It's kind of assignment, no need to submit to me. It's your, homework kind of stuff. You please do it by yourself. It's almost the same. I guess you can, I'll do something here. Oh, I'm not handy. Okay, please bear with me. Oh, gone, I guess. Okay, wait, let me bring it down. Okay, I just want to compare something. This is more. So let me write. This is oh, this is more. This is milli. This is milli machine. This is more machine. The same, the concept, everything is same. But see here, let me tell you the difference. In the case of Moore machine, every state is associated with output. But in the case of milli machine, every input is associated with output. Okay, this is the basic difference between milli and Moore. Okay, it's up to us. And then in exam, if I ask you to design an automata with output, it's up to you whether to design a Moore or milli. Types of the machine, whether to design milli or Moore, you have to. Now, I do for this checking and all. Let me choose this 01. Starts from Q naught. This, this. With Q naught with 0 input, Q1. Q1 with 1 input, Q2. Q2 with 0 input, Q1. Q1 with 1 input, Q2. Now Q naught with 0 input, it is B. Okay, it's B. Q1 with 1 input, it is A. And then Q2 with 0 input, B. Q1 with 1 input, Q1 with 1 input, A. That's it. Okay. So whenever we find this A, right, we have encountered this 0, 1. So it's the same machine, but different, what to say, a different machine. Now let me take another example. Let me take another example, milli machine. So let's design another example. Let's design a milli machine with, what to say, I just want to take one short example so that it will create an example. Okay, let me take one example. Designed a milli machine which gives the 2's complement of any binary input, which gives the 2's complement of any binary input, of any binary input. So before we begin with this, designing of Mealy machine which provide the two's complement of any binary input, I guess you need to understand two's complement. I guess two's complement is nothing but one's complement plus one. Okay, that's the concept we have learned. And then in my example, right, we are going to assume that carry is being neglected. Carry is neglected. Okay, now let me design the machine and then we'll be explaining. Now this is Mealy machine, so no output will be associated with that one. This is Q1, then 1 by 1, 0 by 0, 1 by 0, comma, 0, comma 1. So what about the input for this one? What about the input for this 0, 1, 0, 1? What will be the output? 0, 1, 0 plus 1 is equal to 0, 1, 1. This will be the output, right? So how to find that one? 0, 1. This is Q naught. This is what? It starts from initial state Q naught. With input 1, it is Q1. Oh, sorry. Okay, initial state is Q naught. Input 1, then what? Q1. Then Q1 with input 0, then Q1 itself. And then Q1 with 1, Q1 itself. So 1, what is the output for this one? 1. What is the output for 0? What is the output for this 0? 1. 0, 1. Okay. And then what is the output for this 1? Q1, 1. Q1, 1. If the value, 1, then input is 0. So what is this? What is this? 1, 0, 1. Something is wrong. Whether something is wrong, please check my machine. 0, 0, then 1, 1, 1, comma 0, this one. 1, 0, 1, 1 is this. 0 is this. 1, 0, 1, 0, and 1, 1, 1, 0. Okay. Okay, fine. Are you getting? What about LSB, then MSB? LSB, MSB, LSB, then MSB. Any idea about this? I guess you have already studied this thing. LSB, MSB. Least significant bit, then most significant bit. See here, input I have considered 101. Input I have considered 101. So 101 is here. It starts from Q naught. Then one input, for one input I have specially assigned output 1. And I'm getting 1 here. And then the transition from Q naught to Q1 is being performed when the input is 1. So it comes Q1. And then state Q1 with input 0. Then I'm getting 1 here. And then again Q1 with input 1, I'm getting 0. So I guess if you're thinking that I'm getting the results as reverse way, no. Okay, MSB and LSB position change in the output. You have to find the output in this way. So this is the result, 0, 1, 1. This is the two's complement of a given binary input. This is the machine for that one. So in exam, you should mention the position, like how to check the what answer and all, if you want to be very much specified in that one. Okay, so this is, if you want to take another example, we'll just take 1, 1, 1. The one's complement of this one will be 0, 0, 0. Then plus 1 will be 1 here. This will be 0, 0, 1. So let me check for it. 0, 0, 0. It starts from Q naught because Q naught is the initial state. So Q naught 0, 0, Q naught itself, Q naught 0, 0, Q naught itself, Q naught 0, 0, Q naught, oh, now see here, when it is 0, 0, 0, what will be the output we need to get? One of you just unmute your mic and tell me when the input is 0, 0, 0, what is the choose complement for that one? Choose complement for that one is 1, 1, 1, and then plus 1 is 0, 1, 0, 1, 0, 1, and then I've already assumed that we are going to neglect carry. That's why we are getting 0, 0, 0. Okay, so this you need to understand. And then in exam, I may ask design a milli machine for for finding the ones complement like that. Now, hold on a second. Hold on a second. If I have time, I'll just show you another example, or maybe I'll just go for this conversion. Now, conversion I'll do tomorrow. Okay, so for today, let me just end here. And then it's a request to you all. See, I have designed a milli machine for finding a two's complement of a given binary input as milli machine. So practice this as Moore. And then whatever in the textbook and all, there might be examples for Moore machine. The same you just try out for milli. And then if you happens to encounter any milli machine related example, then try to uh, what to say, design the opposite, I mean, Moore for that one. And then let me tell you another hint, like what kind of question can be asked in such kind of machine. I can also ask the acceptability question in with related to this automata with output. In this case, right, acceptability, you can introduce certain symbols. Like if you design a milling machine which ends with AA, then print A. It means if print one, if it is printing one, then you're going to consider that it is being accepted. If it's going to print zero, then it's not going to be accepted. Like that way also. Okay. Please, so I'm ending this here. Thank you very much.